Hello, this is a video about equivalent fractions. I'm making this video with help from Jagard. It says on the bottom, on the top left-hand corner, and that's because Jagard's here and he's been helping me put this together. What are equivalent fractions, you're asking yourself? And the answer is, it says here, equivalent fractions are fractions that are the same size, but with different numerators and denominators. Let's show you a picture to show you what we mean when we talk about equivalent fractions. Here's a rectangle. I think we'll get a rectangle. Draw a line to cut it in half, and you've got two halves, right? Take a pen and shade in one half of it, and down here is one half. I have shaded in one half of the rectangle, and I've drawn little arrows to remind you that the top number is called the numerator and the bottom number is called the denominator. Okay, now here's what happens if I draw another line to cut it in half again. I've now cut it into 4 equal pieces. Each of those pieces is one what? That's right, they're all quarters, aren't they? 1, 2, 3, 4. I've still got the shading there. How many of the quarters are shaded? Answer, 2 quarters are shaded. Of course they are. So what that tells us then is that since the shading hasn't changed, that tells us that 2 quarters and 1 half are the same thing. They're worth the same quantity. They've got different numerators and different denominators. I'm going to rub that out just to make it a bit easier to read. They've got different numerators and denominators, but actually they're the same size as each other. And that's not all. Those aren't the only 2 fractions that are the same as each other. If I divide this thing into 8 equal parts, and take it from me they are equal, even though they don't look it, then I've got 8 eighths, haven't I? I can write down, I'll just write down one just to confirm. There we go, there's 8 of those, isn't there? There's one, there's another one, and so on. There's 8 eighths. How many of those eighths are shaded? 1, 2, 3, 4. 4 eighths are shaded, which tells us that 4 eighths is the same as 2 quarters, is the same as 1 half. Those are equivalent fractions. Equivalent fractions. Fractions with different numbers in them, but which are worth the same. That's basically what equivalent fractions are, but we're just going to give you a golden rule to help you find equivalent fractions, if you're asked to, and we'll work through a couple of examples to show you how it works. The golden rule for finding equivalent fractions is this. Whatever you do to the top, you do the same to the bottom, and vice versa. That means the other way around. So in other words, if you do something to the bottom, you do the same thing to the top. Let's look at some examples. Whatever we do to the top, we do the same to the bottom, and the other way around. In black, 2 fifths equals how many 15ths? I've already drawn in the arrows, Jagard and I, to show you what happens. We look to see that we've got, I'm going to get the blue pen out, we've already got both denominators. We've got denominator here and here. 5 has become 15. What do you do to 5 to make 15? You times it by 3. Whatever you do to the bottom, you do the same to the top. It's the golden rule. So we do 2 times 3, and 2 times 3 is 6, which means that 2 fifths is equivalent to 6 15ths. Underneath that in red, we've got 4 twelfths equals a certain number of thirds. Well, we've got both the denominators. What's happened to 12 to make 3? What do we do to 12 to make 3? We divide it by 4. We've got smaller this time, haven't we, by the way? We noticed you can get bigger or smaller with this. Doesn't make any difference. Both perfectly possible. 12 divided by 4 is 3. So we then divide the numerator by the same thing. Whatever you do to the bottom, you do the same to the top. 4 divided by 4 is 1. And there we go. There's your answer. 4 twelfths is equivalent to 1/3. Here's a couple more examples before we stop. Here, it's the first fraction that's missing something. The first one's missing a denominator. We've got 10 over something, we need to find what that is, equals 30 over 33. So we've changed the top. We're going to work backwards here because we've gone from 30 to 10. What do you do to 30 to make 10? You divide by 3. So we do the same thing to the bottom. What you do to the bottom, you do the same to the top, and vice versa. Oops, sorry, got the wrong number there. That's stupid, isn't it? Divide by 3. How many 3's make 33? Well done. 10 elevenths and 30 over 33 are equivalent fractions. Last one. What have you done to 5 to make 45? Got bigger, you've times by 9. Do the same thing to the top. 1 times 9 is 9, and that gives us an equivalent fraction of 9 over 45. 1/5 and 9 over 45, they're all worth the same. They're both worth the same size. So that's equivalent fractions. Golden rule, don't forget it. What you do to the top, you do the same to the bottom, and the other way around. The same thing the other way around. That's equivalent fractions. Thanks to Jagard for his help making this. That's the end of the video.